let's continue working on the sample problems for section 11.1, and we'll begin with question number 24. On 24, we have genetics of cystic fibrosis. Cystic fibrosis is one common inherited disease in North America, and that includes the U.S., occurring in about 1 of every 2,000 Caucasian births and 1 in every 250,000 non-Caucasian births. Even with modern treatment, victims usually die from lung damage by their early 20s. If we note a cystic fibrosis gene with a little c and a disease-free gene with a capital C, since the disease is recessive, then the only little c person will actually have the disease. Such persons would ordinarily die before parenting children, but a child can also inherit the disease from two parents that carry one recessive gene and one healthy gene. They have no symptoms but are called carriers of the disease. This is like a pea plant inheriting white flowers from two red-flowered parents that both carry genes for white. Okay, find the empirical probability to 4 decimal places that cystic fibrosis will occur in a randomly selected infant among U.S. Caucasians. Okay, so Caucasians, it said 1 of every 2,000. All right, and we want to write that as a decimal to 4 decimal places. So 1 divided by 2,000, we get 0.0005. My calculator says 5e negative 4. This is scientific notation. The e is the power of 10 that we have. And what that's saying is move the decimal point 4 places to the left from, right now it's located right there. So past the 5 is 1, 2, 3, 4 places. Okay. All right, our next question is 26. Let's look at that one. And it says, among 150,000 North American Caucasian births, about how many occurrences of cystic fibrosis would we expect? So we want to take our number that we just got and multiply that times the number of births, so that would be 150,000. Okay, times 150,000. Make sure you get enough zeros on there. We would expect 75. Okay, we're still talking about cystic fibrosis. Construct a chart similar to table 3. So let me draw that. We have this, capital C, little c, 2 capitals, lowercase and a capital, and 2 lowercase. Okay, so there's our chart. And the first child will be a carrier. Which ones are carriers? These are the carriers. So it's 2 out of 4, which is 1/2. Number 30. All right, suppose a child born to one cystic fibrosis carrier and one non-carrier. Find the probability of each of the following. So let's make a new table. So 1 is a carrier and 1 is not. So there's our table. What's the probability the child will have cystic fibrosis? None of them have the lowercase. So The probability would be 0 on number 30. And if we do 32, child will neither have nor carry the disease. And actually that's going to be, they don't have it and they're not carrying it, so that would be 2 out of 4, which would be 1/2. Okay, let's look at number 42. In number 42, if the probability of E, of an event E, is 0.37, find the odds in favor of E. Probability of E is 0.37. So that means we have favorable 37 out of the total. Notice in probability we want to talk about the total, because this is 37 out of 100. So that means the unfavorable, in order to get a total of 100, would have to be 63. Okay, so in 42, the odds in favor of E would be 37 to 63. That's part A. Part B, the odds against E would be 63 to 37. And that's all we have. Okay, let's go to 44. In 44, if the odds against E are 10 to 3, find the probability of E. Odds against E are 10 to 3. Okay, so to get the total possible, we have to add the 10, the total, and the 3. So the total possibilities would be 13. So this odds against E, that means the favorable is the second one. So it would be 3 out of 13. Okay, and let's do 54. In 54, 6 people, which are 3 married couples, arrange themselves randomly in 6 consecutive seats. Find the probability of each event in exercises 53 through 56. In each case, the denominator of the probability fraction will be 6 factorial, which equals 720, the total number of ways to arrange the items. So we know that we have 3 women and 3 men. So in 54, it says each man will sit immediately to the left of a woman. So we have our 6 seats, and as I've mentioned before, I am a visual learner, so I like to draw pictures. The men have to sit to the left of a woman. So the first choice for a man, I have 3 choices. Then we have to choose a woman. We have now 2 men left, 2 women left, 1 man left, and 1 woman left. So 9 times 4 would be 36. So it's 36 out of 720. And we can see clearly how I was using what we learned in the previous section, previous chapter I should say, in order to count. So I have 1 out of 20. And let's try 56. We'll do one more of these. Okay, again, 6 factorial is 720. The women will sit in 3 adjacent seats, as will the men. Okay, so in this case, we can have the women and then the men, or we can have the men and then the women. There are only 2 possibilities for that. So within the group of women and then within the group of men, same thing here, Same thing here. So we end up with 2, and I'm getting the 2 from 2 possibilities, times 3 factorial times 3 factorial. So that's going to be 2 times 6 times 6, 1272, I believe, out of 720, which is 1/10. Okay. And I use fractions most of the time unless the numbers are icky or it asks for the answer in decimal form. Here it doesn't specify, so I'm going to leave it as a fraction. But you could do it as 0.1 and 0.05 here if you want it. Okay, that wraps up section 11.1.